My name's Aleck, and I don't know what Debbie has told you about me. Don't believe any of it. Just kidding. So I've been in service now for about 5.5 years. So coming up on 6. I been working on discovery for pretty much the most of the time. I mean, there's some offshoot projects here and there. So anyways, today I'm gonna talk about MIS server and discovery, and a huge portion of this will be focused on the majority of this bootcamp session. We focused on the architecture of the MIS server and instance, and then I'll talk a little bit about discovery toward the end, just so that you understand what it is. Okay, so before we get started though, there's a couple of things I want to sort out. So do you guys all have your Eclipse instance, or if not, you should have a instance in the cloud, right? Okay, and then can you guys have you guys enabled discovery?
Not yet.
Not yet. Okay, awesome. So
It is in the prerequisites, but not everybody did it.
okay, cool. So if you haven't, please navigate to the plugins module and then activate discovery. So what it looks like is you go to plugins and then search for discovery, and then you should be able to just right click on that and say activate upgrade on discovery. So if you haven't done that, so that takes a little while, so I want to get that out of the way so we don't end up coming back. And if you're not seeing discovery in the list of plugins, that means that you do not have maint access. So if you do not, let me know. We need to figure it out. Okay, and for those of you who are a little more advanced if you already activated discovery, there's something else I want you to do. There's a prepackaged MIS server that's already ready to go to be installed. So I would like you to basically download it first. So just follow the instruction on the slideshow. Basically scp the mid.osx.zip. If maybe I could help you activate the plugin. If you can send me in chat what the instance name is.
Sure, I was.
Yeah, so to sort of explain a little bit, there are only actually about 2 plugins that require maint access. They're discovery and orchestration, and that is because our customers have to pay extra for discovery or orchestration. So that's why they typically have the customer request the activation of the plugin after they bought it, of course.
Open a terminal?
Yeah, so if you here's what you can do. Open up a terminal. If you don't have it, you can do command spacebar, and then you can find your terminal program. Once you're there, you can simply just follow the command that I had on the screen. So in this case, so one thing that I want you to know is that make sure you know where you downloaded to, because we're gonna have to come back to it. And so in the past, the people downloaded and then they forget where they put it. So typically, if you open up a terminal, it's just in the home directory. So you can just paste it and you can download it. It shouldn't have any problem. So it should look like that. Okay. The password is disco. Okay, so let me get started. We're gonna be talking about MIS server and the ECC queue. So I know many of you have varying degrees of familiarity with our instance. So I'm gonna try to help you understand what it is, even if you never heard of it. So MIS, obviously the first question is what's the MIS server? And I'm sorry if you already know this, but basically it's conceptually it's the instance hands and eyeballs, right? So it help us. It enables us to reach out to our customers network and being able to get information or to execute certain commands. It's basically a Java software application. Can run on Windows, Linux, or in this case, Mac OS. Officially, we only support Windows and Linux for our customers. Internally, we could use Mac OS. It's typically installed by the customer on a host that's connected to the network, obviously. And the whole point here is that we don't want our customers to punch any firewall, any holes in their firewall to allow our instance to talk to the MIS server. So basically, the MIS server always makes an outbound HTTPS request to our instance. Okay. So basically there's a thread that basically pulls every 15 seconds to say, hey, do I have something to do on the instance? Also, it upgrades automatically with the instance. So as the instance moves from, say, Calgary to Dublin to Eureka to Fuji, the MIS server automatically will look at the version it's supposed to be on and upgrade itself. Okay. So what does it do? It basically is controlled through the instance. The instance is typically what we call the brain of the operation, right? So the MIS server says connects to the instance saying, hey, do you want me to do something? And then and if the instance has something, the MIS server will grab that and say, okay, I'm gonna execute whatever you want me to do. There are a lot of protocols that we've built into the MIS server. It's capable of talking with SSH, SNMP, WMI, SIM, HTTP, SOAP, REST, PowerShell, and what have you. So it's pretty, there's quite a bit of I guess versatility that the MIS server brings to the table. I mean, obviously there's more we can do depending on the particular integration and things. It is used for imports, discovery, orchestration, and integrations. So it's not just typically when in our company, a lot of people think the MIS server, they sort of think of discovery associated with it, but it's actually very much used by orchestration and our integration team as well, when it comes to integrating with a third-party software or for orchestration to actually execute commands to do something. Currently, it is stateless, meaning that you can install as many MIS servers as you want to, and they do not keep any state on there. And when you restart the MIS server, anytime it would just it would pretty much be back to where it's supposed to be. So because like I said, the instance is the brain of the operation. So anything that the MIS server needs to do comes from the instance, right? So if the MIS server, say it's in the middle of executing something and it dies, that's not a problem. You restart the MIS server, you figure out what was wrong with it, restart it, and it's gonna pick up right where it left off. Okay, so this is a visual diagram of what that looks like, right, in the architecture. So you can see the MIS server is within our customer's network, and it basically goes through. It could go through a proxy, and goes through the customer's firewall, and then hitting our instance that's on the internet somewhere, right? So as you can see here, MIS server, you can see the arrow. It communicates to the instance, and it also communicates to whatever internal devices there are within that network. So typically, the installation is fairly simple. There's a module called MIS server that comes straight out of the box as soon as you have the instance enabled. You can download. You go click into the download page. It'll allow you to download a zip file. We support 32-bit, 64-bit MIS servers. If you're interested in as a developer, you can run it directly within Eclipse, and that's what a lot of us do run on the automation team. That's what we do, obviously to develop and troubleshoot the MIS server. And so it's basically just need to import a MIT project from Git. And then you can just launch it after you configure it. But for the purpose of our exercise, I already pre-packaged a MIT server which you downloaded. So later on, we'll unpack it and install it. Okay, so we're gonna talk about the ECC queue. ECC stands for External Communications Channel. Basically, the MIT server communicates with the instance through the ECC queue. Now, the ECC queue is nothing more than just a table. Currently, it's a table that says MIT server go do something, and when the MIT server does something, it sends something back into it. So you can think of the ECC queue as sort of a Grand Central Station, if you will, of moving things along, right? Where it collects everything, and everything comes in, everything goes out, essentially. And the MIT server use SOAP web services to query and insert records. That should be fairly straightforward. And then each record in the ECC queue represents a single self-contained unit of work that MIT server needs to perform. So as I said, there's a concept of the MIT server output record that represents a unit of work that a MIT server can pick up and do something. And once the MIT server finishes that task, it then sends back the payload back to the ECC queue table as an input record. Okay, we'll go through that a little bit more later, but that's the general idea. So here's a visualization of what that looks like, right? So you got your instance on the upper left-hand corner, and you have your ECC queue table on the instance. So very first thing, it's obviously you have a chunk of work for the MIT server that's specified in the ECC queue. Then the next thing that's going to happen is the MIT server, every 15 seconds, it's going to come in, make a SOAP request to the instance and say, hey, do you have anything for me? So the instance say, hey, I do have something for you, and I want you to SSH to this particular IP address, and I want you to run a command, in this case, say unam-sp. Now the MIT server grabs that command and it says, oh, cool, I'm gonna, I need to run an SSH command against this particular IP address, and it launches that command against it, and obviously the target is gonna respond if you're able to connect to it. And then in this case, the target's gonna respond, oh, I'm a Linux i686. So the MIT server gets that and then package that up into an XML file, and then sends that back into the ECC queue. Okay, I think that's pretty straightforward, right? Any questions?
Quick question.
Yeah.
No instance.
That's a very good question. Good question. The instance actually specified in a table called credentials table on the instance. And when the MIT server starts up, one of the things it does is it communicates to the instance and downloads a list of credentials, and it stores in memory on the MIT server until MIT server dies.
So you are saying that in our table, from our instance, it contained the SSH password.
That's right.
Customer's premise.
You have, yeah.
Yeah.
Okay. All right.
That's right. Go ahead.
Yeah. This ECC queue will communicate to MIT server for every 15 seconds?
Yes, except the caveat, I will correct that slightly. The MIT server communicates to the ECC queue every 15 seconds.
So is it configurable time?
It is not configurable at the moment. It is just 15 seconds.
Oh.
What is there another question? Or
Yeah, like I thought like we can configure somewhere to communicate like every 5 seconds or every 15 seconds.
I see. Yeah. I mean, that's something that we have thought about, and I think it could come in handy in certain cases. I don't think we have any specific use case at the moment to allow people to do that. I mean, we also don't want people to jack themselves up by changing it to, I don't know, say 1,000 seconds, which would be too slow, or every second, which would be too fast. Okay. Any other question? Go ahead.
So the MIT server communicates with the computers on the customer side, and then it communicates back to ECCQ every 15 seconds.
Oh, no.
ECCQ
No.
doesn't give work to the MIT server.
So slight correction to that. So the MIT server queries for work every 15 seconds. But once it does the work and has the payload ready, that's actually a different thread that sends back to the instance, and that thread is actually run every second. So meaning that if there's anything to be sent, that thread is gonna be constantly sending things back to the instance. Sorry, is it part of your question?
So what kind of work does the ECC queue send to the mid server?
It could be an SSH command. It could be a PowerShell script, or SSH script for that matter. It can do SNMP. It can do JDBC queries and things like that. So later on we'll go through an exercise where you'll actually construct a unit of work for the mid server and make it do something. So hopefully you'll get a better idea what it looks like. Okay. Cool. All right. So, the last thing I didn't mention was so once the payload or the result gets back into the instance on the ECC queue, at that point there's going to be some sort of business rule that triggers that will then follow on to various processes to say, hey, what do you want to do with this particular payload, right? So in the case of discovery, it's going to say, oh, okay, this particular payload is coming from our discovery application, and so discovery go do something with this data, right? So as you can imagine, in the case of discovery, it could be we're running PS -EF and then you're getting a list of processes, and discovery will try to parse that information and store it to the database. In the case of runbook, it could be not runbook, but orchestration. Sorry, I keep saying runbook because orchestration used to be called runbook, so I'm just old habits die hard. Okay, so in orchestration, you could be executing a piece of script to say, I'm going to update a certain configuration record, things like that. So they have a different path to once the payload comes in, different business rules will trigger to do that. All right, so let me get into a little bit about what is a unit of work on ECC queue and what it looks like. So here's a ECC queue form for a particular record. So on here, this is just where was that? Okay, so this is the form of the ECCQ table, and as you can see on here, it's basically specifying things like, hey, which the agent field specifies which mid server you want this particular unit of work is meant for. The topic talks about what kind of command or what kind of probe, if you will, what kind of command it needs to be. So as I said earlier, it could be a SSH, it could be PowerShell, it could be JDBC, and what have you. The name field here is is sort of defined depending on the particular type of probe or work it's being done. So in a simple case of a SSH command, the name field can be used to specify the actual command you're going to run. So on here you see it's doing a cat /proc/man info to get memory information. The source field signifies the IP address the mid server needs to go after. So in this case, it's talking about it's specifying a particular one. Response to, don't worry about that. The queue field basically signifies if this is an output or an input queue. So in this case, you're seeing an output ECC record. So you know that this is meant for the mid server to pick up. Okay. The state field just says it's ready or processing or processed, and then everything else is sort of just peripheral data that you sort of for your information. But the point is that there are 5 or 6 fields that are most important: the agent, topic, name, source, the queue, state. Those need to be specified properly in order for the mid server to pick up. So here's an example of what happens after the mid server has picked it up and executed the command and sent it back to the instance. So in this case, everything almost looks the same. Your agent, your topic, your name, your source pretty much looks the same. You notice the queue is different. The queue is an input, so you know that this record it came back from the MIS server. And then in that case, you can look at the payload field, then you will see that there's actually results in there, right? So this is the result after I have run, or rather after the MIS server has run cat/proc/main-info. So it just gives you back the memory information and whatnot. Makes sense so far, right? Okay. All right. So now we're gonna actually get hands-on, right? So it's cool to know what it is, but I think it's even cooler if we can actually make it work, and you can see how that works. So the first thing first, I want you to install the MIS server on your computer. So earlier you had downloaded the MIS server onto your laptop. So basically the next step I want you to do is basically unzip that mid.zip file that you have downloaded, and you can unzip it either, find out where it is. You can unzip it either by double click on a zip file, or you can open up a terminal and do just unzip followed by the file name. Okay. So before you start running it, there's something else we need to configure. So in that folder, there's if you see the agent folder, you should drill into it. There's a /config.xml file, and in that /config XML file, there is a what do you call it? The parameter tag with the attribute name URL. So in the one that you downloaded, by default it's set to your local host. So it's localhost colon 8080. If that's what you're using, okay, then you don't have to do anything. Just leave it be. If it's not, say you're like John, you're using an instance in the cloud, then make sure that you modify the URL value to HTTPS, okay, and then followed by the instance name .service-now.com. Awesome. Okay, so the next step, once you have configured the config.xml, obviously just go ahead and use the start.sh script to start it up.
Get back running PID some number, right?
Yeah.
Yes.
Yeah, if you see that, then you're ready to go. One of the things the first thing you want to check is, now that the MIS server is started up, the question is, did it actually connect to the instance that you would expect, right? So the way you do that is by going to the MIS server table, and you can check to see if you have the MIS server automatically register itself in the MIS server table. So the copy of the MIS server I gave you already has a name called local _Mac_server1, and you should, if you don't see it there, then that means that there's a problem from the MIS server to communicate to the instance. Okay. Okay, that's fine. So there are a few things that we need to check to make sure. So this is a good learning process. So what could go wrong, right? So number one, I would check to see. So in the MIS server config.xml, the username and password that allows the MIS server to communicate into the instance. For our purpose, I used admin with the password admin. So if that user doesn't exist on your instance, make sure that you go to your user table and make sure the admin credential is available.
Oh,
okay. So if your config.xml, if it is actually the username says MIS server, you have two choices. Either you can go to the instance and create a username MIS server, and with the password also is the same as the username, also MIS server, all lowercase, one word, or you can change it on the config.xml file to just admin. And I apologize. I think I got mixed up in the package that I gave to you guys. I thought I configured admin in there.
password needs to remove the encrypted string.
1 second here.
Yeah.
So in the password, yeah, you need to remove the encrypted and basically just do oops. So the if you're just curious, the encrypt equals true. That just allows it to so like the way I've typed on my screen, it's admin. But once it connects to the instance successfully, it'll actually rewrite it into the encrypted form. Okay, that's fine. If you're having issues, oops. The next step is so I mean, make sure that the username on the instance correct, and make sure your URL is correct. If none of that work, then the last thing you want to the next thing you could do is actually look at the log on the MIS server. So in the agent folder, there's a log directory.
Yep, I got it.
So in the log directory, you'll see an agent0.log.0. So look at that to see what it tells you. Yeah. So if anytime there's something wrong, I would take a look at the MIS server log just to see. So now that you have your MIS server up, the next thing we're going to do is basically configure the credentials table. Well, actually, before we even do that, I want to explain what we're going to do. So the objective here is actually for you to make my computer talk. Okay. So there are two things I need to give you. The first thing I'm going to give you is the credential to access my laptop. Okay. And the second thing I'm going to give you is my IP address, so that you know where to target it. Okay. So the first thing was going to configure the credential table. So go ahead and go to the credentials table under discovery.
Okay.
Yeah. So go ahead and click new, and then sort of follow my example. So let me type into the chat what the username and password should be. So the username is discover me. The password is disk0. Okay, so once you have that, go ahead and save the record, and it's gonna be automatically pushed to the MIS server once you do that. So the MIS server will have the credential to my laptop. Okay, so the next thing, if you haven't realized already, is that on a Mac you can actually make your Mac talk anytime, right? So for example, I can make my Mac say anything. 1 second here. So for example, I can type say hello world.
Hello world.
And then my laptop will say hello world.
Hello world.
So I want you to do the same thing, but to my computer and through the MIS server. Okay. So I'm gonna give you my IP address, and before I give you my IP address, I just want to let you know that this is my laptop, and I work with this laptop, so do not do anything to me, okay? Please. I mean, I think I locked it down to a point where I think it's mostly read only, but you know, I'm sure there's places I didn't lock it down. So, okay. So I don't have any grudge against you, so you know, don't give me any reason to. So the let me see, my IP is, I'm gonna type in chat. 1 second. And okay. Okay, here's my IP address, 10.0.68.107, and I'll walk you through what that how to construct a record, right? So go ahead and navigate to the ECCQ table. So once you navigate it to the ECCQ table, the very first thing is you want to do is specify which MIT server you want to use. So in your case, it is mit.server.local _mac _server1. Okay. Then the next thing is topic. It's called SSH command. Okay, here we go. So in the topic, I want you to type in a SSH command. It does matter. The casing does matter. Okay, so it is uppercase SSHC, and the rest lowercase. The name is the command you're going to run. So in this case, you can do say hello world, but I want you to be creative. Okay, so surprise me what you're gonna say. The obviously the password. Is this is the password here? Sorry, not password. The IP. Sorry, IP address. Sorry, I was looking at something else and saying it. And then the Q is output. So let me know when you're here. Basically, this is you're constructing a single unit of work for the MIT server to do, right? So for your MIT server, you wanted to execute SSH command. You wanted to say hello world, and then
Harry is the man.
awesome, somebody did it. Awesome. How do you debug it? Okay, that's a fair question. So the very first
Hello world.
thing that that you will take a look at is obviously the ECCQ record that you created. So the very so in this case, you would say you would look at it, your ECCQ output, to see if it's been picked up, right? So so in this case, say I created an ECCQ output record for the MIT server to pick up. If it stays in ready state, that means that your MIT server never actually processed it, right? So in this case, you can see it's processed. So that means my MIT server actually picked it up and it did something, and it actually executed a command back. That's how you would know. If the output record stays ready, stays as ready, that means MIT server didn't pick it up. Then the natural thing to check is to go to MIT server table and to see if your MIT server is actually up and running. So in my case, you would see. I mean, in this case, you would see the status being up or down. If it's up, then that means that the MIT server is somehow, well, it's not likely that it's up and not actually picking anything up from the ECCQ. So chances are it's probably showing down. Then you have to go to the agent log on the MIT server to see what's wrong with it. So the very first thing I'm going to do is I'm going to change the password.
Did you have disco 0 or disc 0? I mean, disco 0 or disc 0?
All right, so I'm going to go ahead and change the password. So if anything you want to execute now is the time.
When you do run again, does it send it again?
Yep, if you do run again, it just automatically sends it again. All right, I'm locking it down. All right, let's move back to our presentation. And so first of all, I want to apologize that if it's chaotic, and I hope that that you understand that this is actually probably the best way you can learn something, right? So like there's chaos, there's things that you troubleshoot, and you're understanding more in terms of how everything works. I also learned a lot today. I'm just been thinking about what's the best way to basically improve the setup experience, because obviously there's issues with the credentials. There's obvious things like how to troubleshoot credentials, what's wrong with it, and I think there's a lot of things that can be improved upon. So I thank you for that. Even just good for me to see that. So I want to continue on and with the MIS server, and then hopefully by now you understand what how the MIS server works, right? So obviously in our product, you would never for any customer, you would never construct a single unit of work for the MIS server to do. It's typically wrapped by discovery or orchestration and things like that, right? But as developers here, what I really want you to take away, if anything at all, the takeaway here today is for you to understand how the MIS server really communicates with the instance and how you can give MIS server something to do, okay, and how that process really works. So continue on the MIS server. There are some other features that's worth mentioning. We have clustering capability as well. It has load balance capability as failover. It's a fairly simple, straightforward way of clustering. It's nothing too fancy at the moment. It could change in the future, but for now that fits our use case. It's also got things like capabilities and IP ranges you can specify on the MIS server, meaning that you can say if a MIS server is capable. MIS server is capable of performing SSH, PowerShell, or SNMP, so on and so forth, and which IP ranges it's capable of discovering. Because as you can imagine, typically in a customer's network, they probably have VLANs that probably don't even talk to each other. So typically what we tell our customers is that, hey, for the network segments that do not talk to each other, go ahead and put a MIS server in each one of those networks, so that you don't get into a situation where the MIS server is talking. Say you install a MIS server in America and it's talking to Asia, going across the WAN. Typically, we don't want things like that to happen. We want a MIS server on that particular network to discover the devices within that network and send the traffic back to the instance through the WAN. Okay, there's additional things you can look at in terms of MIS server. There's performance reports and resource usage that's built into it that you can see. There's additional customizable functionality, such as you can develop JavaScript probes that allows you to extend beyond what the MIS server can do today. So, for example, you can drop in a jar file onto the MIS server, and you can write your JavaScript probe that basically interacts with the jar file through Rhino, right? Exactly the same way you would do on an instance. If you haven't learned that already. So on an instance, you can write JavaScript and you can call certain functions or methods in Java through Rhino. So it's the same thing that happens on the MIS server as well. You can write a JavaScript probe that allows you to basically reach in to the jar file and interact with it. So that allows our customers to basically drop in a custom jar file of their choice, and then they can interact with it, to whatever third party. So an example of that in terms of what we do is for, say, VMware integration, we're capable of talking to VMware vCenter and being able to grab information such as what are the ESX boxes, what are the VMs running on it. So we leverage a jar that's provided a third party, and basically that allow we then write the JavaScript probes to talk to the vCenter and grab that information. So I've known of a couple other customers who have done similar things with mainframes to leverage the similar scheme to get that done. Any questions? Okay, so that's pretty much it. In summary, once again, if there's anything that at all that I want you to take away is really understand the architecture here between the MIS server and instance and what it's used for. Again, the instance, the brain, the MIS server is the hand that reaches into the customer network, and the ECC queue is a table that allows that communication to happen. That's pretty much it in terms of this session. Any questions?